Hi everyone, in today's lesson we're going to be talking about graphing quadratics in standard form. This is Mrs. Pagan working with you again. Alright, so let's talk about the three different forms we have. First is the vertex form. We talked about this form quite a lot. Basically, it helps us find the vertex. That's where it gets its name from. Then we talked about the second form, which is the intercept form. This helps us find our x-intercepts. And now we are going into the standard form. Standard form doesn't tell us much unless we use our calculators. So that's what we're going to be doing today. All right, let's start. Now, all the steps I'm going to be following and doing are written in your notes right here. Just follow through with me. If you cannot, pause me, please, and or rewind so that you can understand what's happening. But know also that they are written for you here. So let's start with example 1. In example 1, it says identify the vertex, the direction that the parabola opens, and state the axis of symmetry, then graph. So we're going to fill in all this information and then we're going to graph it. Now, I am going to utilize my calculator because I can't even tell what the vertex is by looking at standard form. So I'm going to take out my TI-84. I'm going to go to y equals, and I'm going to clear what I have and put in my new equation. Negative 2 x to the second power. Then we have negative 4x and plus 6. So let's go ahead and graph our equation. That's what it's supposed to look like when I graph it. All right, now I can't tell what the vertex is, so what we're going to do is let the calculator calculate our vertex for us. So I'm going to go to second, trace, and what you'll see on top is this calculate. So we're going to calculate this information. Since the graph was upside down, we know that the vertex is at a maximum location. So we're going to go ahead and calculate maximum. Notice, that's a maximum. The question now says, are you left bound? Meaning, are you to the left of this vertex? And that's not left, that's right. So I have to move this cursor to the left, and I'm going to do that by pressing the left arrow several times. All right, now I would say I'm to the left, so I'm going to go ahead and press enter. Now the question changed, and the calculator is asking, hey, are you right bound? Are you to the right of this now? And I'm not, so I'm going to get to the right of it by pressing the right arrow a couple times. And I'm going to press, now I am, so I'm going to press enter there. And now you'll see these arrows facing each other. The calculator is saying, so should I guess that it's between these two? And I'm going to say yes by pressing enter again. And it's going to calculate our maximum at negative 0.9999. Now that means to me negative 1, comma 8. So our vertex is at negative 1, comma 8. So we're going to go ahead and put our vertex down as negative 1, comma 8. Now we can identify whether it opens up or down by looking at the A value. So that's that right there. Since A is negative, we know that it opens down. And since it's facing down, it looks like this, we know that the vertex is actually a max. It's a high location. It's a maximum. And since we have the vertex, we can use the x value to figure out what the axis of symmetry is. So that'd be in a line, x equals negative 1. All we have to do is now figure out what the point on the left is and point on the right. So I'm going to use my calculator and use my table. So I'm going to go to second, graph to get the table. The bell just saying, whoa. And now we're going to go to negative 1, 8. There's negative 1, 8. And negative 2, 6 is the point to the left. So I'm going to do negative 2, comma 6. And then let's grab the point to the right. That would be 0, comma 6. So I'm going to go ahead and grab 0, comma 6. So let's plot these 3 points. We have a point at negative 2, 6. There it is. We have a point at negative 1 and up 8. And then we have a point at 0, comma 6. And we know that this is supposed to look like a U, so I'm going to make it look curvy and hope that it looks kind of like the image that we saw in the graphing calculator. Let's check it out. Yeah, that looks about right. Look at that. Cool. Now, there are 2 other questions that we want to answer, and the questions are asking, hey, are these real solutions? Now, real solutions are where the graph touches the x-axis. So I'm going to just kind of zoom in here. I can tell that the graph is touching the x-axis in two places, and I don't know if it's exactly at -3 and 1, but I know that there are two real solutions. So that's real. I can see it with my eyes, and that's real, which means there are 0 imaginary, because my total is supposed to be two solutions. And the reason I know that is because it's a quadratic, and quadratics have always two solutions. All right, so since I already have the 2 here, then that leaves 0 for the imaginary. When I add them up, I'm supposed to get two solutions total. Two total solutions. All right, so that helps us out. It touches, the reason they're real is, by the way, because it's touching the x-axis. So that's where solutions tend to be. All right, let's look at example B. We're going to repeat the same process again. So we are going to put y equals x squared minus x plus 7 in our calculator. So go to your y equals again, clear what you have here, and let's retype it. X squared minus x plus 7. And then I'm going to go ahead and graph the image. Ooh, look at, it's not touching the x-axis. Ooh, that's interesting. So we'll talk about what that means. Let's find the vertex. Now, it looks like the vertex is somewhere here. And we could tell that it's a low spot. It's a minimum. It's a valley. So I'm going to go to second trace to calculate a minimum, which is number 3. So go down to 3 and enter. And the questions have started. Are you left? I am, but I'm not really sure. So I'm just going to go a little bit more to the left. I am for sure left now. And then now the question has changed. Are you right? And I'm going to keep going right. I don't want to get too close to the minimum. I can't tell. So I'm going to keep going to the right until I'm like, okay, I'm for sure to the right now. Enter. Do you want me to guess between these two lines? Yes, please. Guess calculator. And enter again, and there it is. Now, this is 0.49, so we know that's 0.5. And this is 6.75. So our vertex is at 0.5, comma 6 point, and I forgot already, 75. There we go. So that's where it is. It's not at a nice number. It's the 2 decimals, but that's okay. We can also see if it opens up or down by looking at the sign in the front. It's positive, so we know it opens up. And by graph, we can see the graph that because it opens up, that vertex is a minimum. It's a low spot, so we know it's a minimum. It looks like this. That's a min. Axis of symmetry is going to come from the x value, so x equals 0.5, and we need a point to the left and point to the right. So we're going to go to our table. Go to second graph for the table. Now, the vertex is between 0 and 1, so I'm going to grab the left point, which is 0, 7, and the right point was 1, 7. So that would be to the right of the point of the vertex. And you'll see it when we graph it in just a second. So let's change our color a little. We have 0 and up 7. Here's that point. We have a half and 6.75. Like that. It's so hard to see. And then 1 and 7. So you can kind of see the difference. And we know that it's supposed to be a U. So we're going to mimic a U, so that's our U, and you can see that it's starting just like the graph did up top. It's not really touching the x-axis. Now, because it's not touching the x-axis at all, there are no real solutions. So when they ask us about real solutions, we know that there are 0 because the graph doesn't touch the x-axis. But we know there's got to be 2 total solutions, so then the other 2 must be imaginary because 0 plus 2 has to add to a total of 2 because we have an x squared, and the squared means, hey, there's got to be 2 solutions. So that is pretty much all I have for you guys today. You guys did an excellent job. If you need to watch it again or read the instructions on how to type this in the calculator, all that you need is written in these descriptions here. I hope it was helpful. Looking forward to seeing you in class. Have a great day. Bye bye.